Welcome to the relative dating worksheet. Hopefully you guys are working along with me here. This is going to be the first 31 points of this worksheet. So most of the worksheet here we are going to do together, and you're going to answer, let me see if I can scroll down. You'll be answering this one and this one on your own, and then a little reflection at the end there, and that's about it. So we're going to do all of this together. So hopefully you are listening with your volumes up. Okay, so relative dating is not dating your relatives. Sorry, I had to yawn there. It's not dating your relative or dating rocks. Like that's ridiculous. No, it's so relative actually means in comparison to, or you're comparing two things. So we're comparing like two rock layers, for example. We're going to say this one is younger than this one. Okay, so that's all we're doing here. We're just saying younger or older. We're not giving them any actual ages. We're not doing anything super crazy with them. We're just saying younger or older. Okay, and how do we do that? When sometimes rock layers get really, really messed up, well, there's a couple of principles that we can follow. So let's look at some background information here on what relative dating is. So I'll read this for us. Before the theory of evolution was proposed by Charles Darwin in 1859, geologists had already noticed that fossil groups changed from one stratum layer to the next. This concept is termed fossil succession. For example, geologists noticed that a lot of mammal fossils were higher stratigraphically than the number of reptile fossils. Geologists were able to use fossil succession of fossil groups to connect and relate distant rock layers to each other. These connections led to the making of the geologic time scale, a global record of rocks and their relative ages. However, before scientists can relate the ages of rocks in different areas, they must first figure out the ages of rocks at one single location. Within a single location, geologists are able to determine which rock units are the oldest and which are the youngest. This type of study is called relative age dating. The principles of relative age relationships are listed below. I have highlighted the ones that we are going to be using on this worksheet. The two that you are doing yourself, you will not be using this one, but these other two you will. So first off, we have the principle of superposition, and superposition is one of your vocabulary words for this reason. It states, in a sequence of undeformed sedimentary rock layers, the rocks get older from the top to the bottom. The bottom layer is the oldest layer and the top layer is the youngest. So it's just simply saying that if rock layers are in these nice straight rows, the oldest is on the bottom, and then the next one's deposited, and the next one's deposited, and the youngest one, the most recent one to be deposited, is on the top. The principle of original horizontality says that when sedimentary rock layers are being deposited, gravity forces them to be deposited as flat, horizontal layers. Once the sediment has solidified and become rock, they can be tilted or folded. So it's just saying that they get laid down in nice flat layers thanks to gravity, smoothing everything out and filling in all of the pits and potholes before it solidifies into a rock. Once it solidifies into a rock, this kind of stuff can happen. Okay, so originally, rock layers are laid down in nice horizontal layers. Number 3, the principle of fossil succession. We kind of just read a little bit about it up there. Groups of plant animal fossils appear in the geologic record in a certain order. These fossil groups can be used to identify certain periods of geologic time. You guys just should have gotten done with your index fossils. Or no, you have that next. Never mind. Next activity you have on level 3 is your index fossil notes. Number 4, principle of cross-cutting relations. An igneous rock intrusion or a fault that cuts across other rock layers must be younger than the layers it cuts across. In other words, the other rock layers must have already been there for an igneous rock or fault to cut across it. So if anything cuts across, like this is cutting across these layers, it's automatically younger than those layers. C, E, and D had to have been deposited and turned into rock before A could crawl through and intrude there. So this is igneous rock. It was lava or magma, I guess, that melted its way through from the mantle below and came up, cut it across, and it spilled over on the surface here, and then B was laid down. So we'll talk about that one later. But let's see, number 5, the principle of inclusion. A rock unit that contains inclusions of pre-existing rocks must be younger than the rock unit from which the inclusions came. So if there's other chunks of rock in a rock layer, it's automatically younger than from where the inclusions came from. Okay, we'll look at one example of that earlier or later. Number 6, metamorphic rocks. A metamorphic rock is always older than sedimentary and or igneous rocks around it. So if you ever see a metamorphic rock, and again, I gave you the key. These are metamorphic rocks right here, gneiss and schist. I know, funny names. If you automatically see those, they are automatically the oldest layer. The metamorphic rock must have formed before the surrounding rocks, otherwise they would be metamorphosed as well. Metamorphic rocks take a really, really long time to form, if you guys remember your rock cycle. So any metamorphic rocks are automatically going to be the oldest compared to sedimentary or igneous rocks. All right, that's an activity we would normally do in class, but we're not going to do that here. Okay, so we are going to look at the following drawings and the symbol key. I gave you the symbol key on the worksheet as well. Then use the relative age principles that we just talked about to determine the age relationships. Typically, geologists will list the age in order from rocks from top to bottom, with the oldest rocks at the bottom and the youngest rocks at the top, like the principle of superposition. Note, you will notice that the top of a boundary of some of the rock layers is jagged. This boundary is an unconformity. That is where a rock layer's surface was exposed to wind and water erosion for a significant amount of time before the next sediments covered it. So I'll show you an example of that here. A good example of that would be like this. It's kind of wavy across here. It was exposed to the surface for a while and weathered down, eroded away, and so it left kind of some jagged areas there, not totally horizontal. Or this right here, this is a bad unconformity on the surface right here. So this layer has been exposed to the surface for a long time, and a lot of this, especially right here, has been weathered away and eroded off somewhere else. So another layer will fill in on top of that, and we'll go on eventually. Okay, so let's look at your worksheet here. All right, so I gave you guys these. We have our sedimentary rocks here. If you see any of those are sedimentary. If we see any of these are igneous. If we see any of these are metamorphic, and remember they're automatically the oldest if we see them. Here's a unconformity. If you see any jagged lines, a fault is going to be a straight line cutting through. Zone of contact metamorphism is where igneous rock kind of gets in and melts and pressurizes some metamorphic rock. So we'll look at that later too. Don't worry too much about that. All right, let's get to work. Make sure you are following along on your worksheet here with me. I am going to tell you to pause this video. You go in and put your answers in. You just click on these little bubbles here and it'll have you enter your text. Make sure you're entering in capital letters just like you see on the rock layers here. I would like you to go in and put in your answers first and then come back and play the video and check your answers, okay? And then you can feel free to change them, whatever you got to do. But I would like you to try it on your own first and then come back and see how you did, okay? So right now you can pause this if you're good to go and go answer your Figure 1 questions. I like to start with the oldest and work my way up to the youngest. I think it's easier to work that way with when things like cut across and all that. So you can start from the youngest if you want to at the top, down to the oldest, totally up to you. But I suggest you pause the video now, go work on Figure 1, and then come play the video again when you are ready. Okay, so playing the video again. Let's check your answers. Our oldest here is going to be on the bottom using the principle of superposition. The oldest is on the bottom, so that would be layer C. Again, type in a capital C, capital letters, please. Our next layer deposited on top of that would be E, and our next layer on top of that would be D. So far we have C, E, D. C, E, D. And then after D was deposited, we have A. So A is that principle of cross-cutting relations. An igneous rock intrusion or a fault that cuts across other rock layers must be younger than the layers it cuts across. So that is basalt. That is an igneous rock that came up from the mantle, melted its way through. So it cut across C, cut across E, cuts across D. So it's automatically younger than C, E, and D. Okay. A, the intrusion is younger than those. It spilled out on the surface for a while, and then B was deposited on top of that, and that is our youngest layer. Okay, so C is our oldest, and then we have E, and then we have D, and then A, and then B is the youngest. All right, so check how you did. Change your answers if you need to. Pause the video if you need to. I'm going to go on to figure 2 here. So look at what figure 2 has. Look at what kind of rocks these are. Go ahead and pause your video. Go answer yours, and then come back to us when you're ready. Okay, figure 2. So if we look at what B is kind of gray with speckles in it. E is white with black lines through it. Gray with speckles in it is an igneous rock. Black with the lines through it, I think more like this, was the schist. That's a metamorphic rock. Remember what we said about metamorphic rocks? If you see a metamorphic rock, it is automatically older than any other rocks around it. So automatically our white with the black lines, E, schist, is automatically the oldest because it's a metamorphic rock. It's been down there for a long time, turning into a metamorphic rock. B is an intrusion, and it cuts across E, but it doesn't cut across any other layers. So law of cross-cutting relations says what it cuts through, it's younger than. It cuts through E, so B is younger than E. Okay, so E was here first, and then B melted its way through. And then C was deposited on top of that. And then D, and then A. That's our principle of superposition. When they're nice straight rows here, the older is on the bottom, younger is on the top. All right, so here we have E because it's a metamorphic rock. It's automatically the oldest. B, cut through, so it's automatically younger than E. And then our nice straight layers here, superposition tells us C is next, and then D, and then A. All right, so how'd you do? Ready for figure 3? Okay, so again, go look at what kind of rocks these are, and pause this video to answer your own, and come back to us when you're ready. All right, figure 3. We have some light gray with speckles. We have some dark gray with speckles. It's all gray with speckles, which is an igneous rock that is basalt. And there's also C with these super wavy black lines, white with black lines. That would be the gneiss here, which is a metamorphic rock. So what do we know about metamorphic rocks? They're automatically the oldest. A metamorphic rock here is C. And then we have two different basalt situations going on here, two different igneous rock. So C is automatically the oldest. A would have melted its way through, pushed its way through kind of and melted away C. Okay, so A is next. And then B cuts across A and it cuts across C. So it's automatically younger than both A and C. Okay, so metamorphic rock situation here and igneous rock intrusion situation there. All right, so we have C, A, B. C was there first, A melted it, pushed its way through, and then B intruded, melted, and pushed its way through across both of them. All right, figure 4. We're getting a little bit crazier now. These were in nice straight horizontal rows, but over time, as we learned about in our last grid, Earth's surface isn't perfect. It's broken up into those plate tectonic chunks, tectonic plates, and has faults and cracks all over it. So faults and cracks cause our rock layers to shift around and fill in the holes, and things get a little crazy. So we're going to try it here. Make sure you look at what kind of rocks these are. Go ahead and pause your video to answer figure 4. Okay, let's check your answers here. The first layer to get laid down, and I'm pretty sure these are all, if you went back and checked, these are all sedimentary rock layers, okay? All sedimentary. But we do have some faults going on here.